Good day, everyone. And once again, we are back together. Your favorite uncle bringing you just another segment of, chemistry. So if you have not subscribed, please just make sure that you're part of the family. All right. And we are going to be looking at acids and bases this time around. Let's get right into it. Okay. Right. So in question 7, they've given us, this is by the way from the November 2022 exam, right? So they say ethanoic acid is a weak acid that reacts with water according to the following balanced equation. Right, now, before we go very far with this, right? So I want you to note in this case, this is how do we identify Lowry-Bronsted acid-base conjugate pairs, right? So if you notice, by definition, an acid would be an H plus donor, whilst the base would be a hydronium ion acceptor, right? So in this case, just have a look at this. So ethanoic acid starts out with an H there, but when it gets to the other side, it has lost that hydrogen, right? Or that hydronium ion. So what does that mean? It means this guy must have donated, right, the H plus. So therefore, that makes this guy the acid. Okay. All right. Let me try and write it nicely. So that makes this the acid. Okay. So of course, if this one is the acid, so therefore that becomes the base. Okay. So if we look at the reverse reaction, right? So H3O plus starts out as H3O plus, but what does it become? It becomes H2O. So it means this guy here must have donated an H plus, right, to become H2O. So on the reverse reaction, this one becomes the acid, and so this one becomes the base. Okay, so remember when we talk about acid-base conjugate pairs, right? It's the acid on the one side pairing with the base on the other side. Similarly, the base on the one side pairing with the acid on the other side. Okay, right. So they say, define an acid in terms of the Lowry-Bronsted theory. So we know that an acid is a hydronium H plus ion donor. Okay, in the Lowry-Bronsted theory. Right. They say give a reason. Okay, so I'm going to try and write that down there, right? So they say give a reason why ethanoic acid is classified as a weak acid, right? Remember, in this case, a weak acid ionizes partially, or we can say it does not ionize completely, okay? It does not ionize completely, right? Does not ionize completely in solution or in water. All right, and we can say that it also forms a low concentration of hydronium ions, right? Okay, so 7.1.3, they say write down the formulae of the two bases in the equation above. All right, so we've done that already. So the one base is H2O, okay, and the other base would be that ethanoate ion, okay, so CH3COO minus, okay. Right, so those are the two bases in our formula. Right, let's go on to the next question. They say a flask contains 300 cubic centimeters of dilute sodium hydroxide of concentration 0.167. They say calculate the number of moles of sodium hydroxide in the flask. All right, so now we've got the volume and we've got the concentration, right? So we know that concentration, so that's 7.2.1, right? Okay, so we know that concentration is number of moles divided by the volume, right? Our concentration is 0.167, I believe, right? We want the number of moles, but we know our volume was actually given as 300. But please remember, we must convert it to cubic decimeters. So we do that by dividing it by 1,000, right? So that gives us 0.3. So if we divide it by 0.3, right? So we can multiply those out. So that's 0.3 times 0.167, and that will give us 0.05 moles. So that will be the number of moles, or those will be the number of moles of sodium hydroxide. Okay, right, I hope that made sense, ladies and gents. Right, so let's go on to the next question. So they say ethanoic acid with a volume of 500 cubic centimeters, so there it is, and an unknown concentration X, okay, is now added to the flask to give a solution of 800 cubic centimeters. Of course, it makes sense. You take two solutions. The one had a volume of 300 cubic centimeters. The one had 500 cubic centimeters. You pour the one into the other, and in this case, you end up with a solution of 800 cubic centimeters, right? And they say it is found that the pH is 11.4. Now, note, ladies and gents, what did we do? We took ethanoic acid and we put it in the sodium hydroxide solution, right? But still the solution comes out basic, right? So what does that mean? It means that it in this case, it partially neutralized, but you still had the base being in excess in this case, right? So this is the resulting solution. So we know that this will give us the resulting solution. The resulting solution has a pH of 11.4. Right, now they say to us the balanced equation for the reaction is given there, and they want us to calculate the concentration of hydroxide ions in the mixture. Right, so now what I'm going to do, okay, is use our definition for pH. So there are two ways of doing this, but I'm going to go with the traditional one. I'll show you the other one. So we know that pH in this case is negative the log of our hydronium ion concentration. Note hydronium, not hydroxide, and we are looking, in this case, they said the concentration of the hydroxide ion. So let's find out what our hydronium ion concentration is. And all you simply do, ladies and gents, just remember to find the hydronium ions, you simply say 10 to the minus pH, right? Okay, so that will be 10 to the exponent minus 11.4, which is what was given there, right? So we can calculate that, and we can say, well, that's going to be 10, that's yx negative 11.4, right? So that gives me a concentration of 3.98 exponent negative 12 moles per cubic decimeters. Okay, so that's hydronium ions, right? But what do I want? I want hydroxide ions. So what I'm going to do is I'm going to use the ionization constant of water, right, at 25 degrees. We know that's equal to the concentration of our hydronium ion multiplied by the concentration of your hydroxide ion. We know this is equal to 10 to the exponent negative 14, right? So we know what this guy is. This is 3.98. Okay, that's 3.98 times 10 minus 12. Okay, and we're looking for the concentration of our hydroxide ions, right? So what does that give us? 10 to the minus 14. So we can divide both sides by 3.98 times 10 minus 14. The same is true for this guy here, times 10 minus 14, minus 12 rather, and not 14. Okay, minus 12. Okay, and we can calculate that quickly. So I'm going to take that and divide by 1 exponent negative 14, right? And I'm going to invert that. Okay, so take the inverse of our of our answer. Okay, and I get the hydroxide ion concentration to be 0.0025, okay, moles per cubic decimeters. Right, so remember that we're looking for the concentration of our hydroxide ions. Now another way that you could have done this is to use pH plus POH, right, being equal to 14. You can find the POH value, right? So that would be 14 minus the pH, which is 11.4, okay, so, which was the value that was given. And when you get the POH value, so that would be 14 minus 11.4, so that would give us that would be 2.6, right? Okay, right. So in this case, because you've got a POH of 2.6, so all you simply do is say POH, that's minus the log of our hydroxide concentration, right? Note this is not pH. And in this case, all you simply do for the concentration of your hydroxide ion, this will be 10 to the minus POH, and that's 10 to the minus 2.6. Okay, and you'll see in this case, should be able to get the same value, right? So that will be 10 yx negative 2.6. And can you see we get exactly the same answer? All right, I know this looks a little bit more easier, 0.025 moles per cubic decimeters. Okay, right, the only trick when you use this method is that you must just remember that you're not necessarily given that formula. Okay, the official one is that is given is both these two, right? Now, let's go on to the next question. I hope you understood this, ladies and gents. Right, let's go on to the next question. They say to us, calculate the initial concentration X of ethanoic acid. Okay, right, now here's what I want us to do, ladies and gents, right? Do you remember that we got the concentration of, or rather at least the number of moles of sodium hydroxide that were initially in the flask? Okay, so what would happen in this case? It means that some of them, right, will neutralize with the ethanoic acid that we poured into the reaction, so that the result gives us that pH of 11.4. So what we have here, the concentration of the hydroxide ion that we have in the mixture, is what was left after, in this case, it reacted with ethanoic acid. So what I want to do is, if this is the result, okay, and these ones here are the initial, I want to know how many of them reacted, okay? So what I can do is I can find out what is the number of moles of hydroxide ions that remain in our mixture, right? So I can say, look, I know the concentration of our hydroxide ions, right? But I also know the volume of the mixture. So I can say, well, number of moles. So this is 7.2. Is it 7.2.2? No, 0.3, right? So 7.2.3. Let's find out the number of moles of our hydroxide concentration, right? And we know this is going to be concentration times volume. We know this is going to be 0.025 multiplied by, now remember, what is our resulting volume, right? Our resulting volume in this case was 800 cubic centimeters, right? That is after we poured that mixture, right? So in this case, this will be multiplied by, remember, it's 800 over 1,000, so that will be 0.8 in this case, right? So that's the resulting mixture after I poured both of the two mixtures, or I mixed the two together, right? So let's do that quickly. So 0.025 times 0.8, and I get a value of 0.02 moles. Now, in this case, I'm left with 0.02 moles after they reacted, right? But I remember that I actually started with an amount of 0.05 moles, right? And the reason for that, why I say, well, remember, sodium hydroxide, when it ionizes, dissociates rather, it forms sodium plus the hydroxide ions, right? So it means that if I know what the hydroxide ions are, I definitely know the number of moles of sodium hydroxide that is there, right? So therefore it means that the number of moles of sodium hydroxide will actually be the same as my hydroxide ion, which is 0.02 moles. So I want to know how much reacted, right? So I'm going to say, so the number of moles that is left in this case, so which means this would be in excess, right? So these are the ones that remained, right? So I'll call them the excess, will be equal to the number of moles that we had initially minus the number of moles that reacted. So I want the ones that reacted, right? Okay. So in this case, I've got in excess was 0.02. Initially, I had 0.05. Okay. So I want to know how many reacted, right? So in this case, that would mean you can see that the number of moles that actually reacted were actually 0.03 moles. Now, ladies and gents, this is important. So this is the sodium hydroxide that actually reacted with, in this case, the ethanoic acid, right? So now we go to this reaction, and it says to us, for every 1 mole of sodium hydroxide, I will use 1 mole of ethanoic acid, right? So because we have a 1-to-1 ratio, so therefore for 0.03, how much will I use of ethanoic acid? It will also be 0.03, right? So I can say, therefore, the number of moles of sodium hydroxide that reacted will be equal to the number of moles of ethanoic acid that actually reacted, right? And that is 0.03, right? And as a result, ladies and gents, I want you to see this as 0.3 moles. Why? Because it's a 1-to-1 ratio. And so because, remember, they wanted us to calculate the concentration X, we know that the concentration X in this case will be number of moles divided by volume, right? Now we've got the number of moles of ethanoic acid that reacted, 0.03, and remember the volume was 500 cubic centimeters, right? So in this case we can find out what that is. So that would be 0.5, right? Remember, it's 500 divided by 1,000, which will give us 0.5. And so as a result, ladies and gents, what are we going to have, right? So that would simply be just twice that. So that would give us 0.06 moles per cubic decimeters, right? So it means that the X amount in this case would be 0.06 moles per cubic decimeters, right? I hope that made sense, ladies and gents. This is one section that really needs a lot of revisits, but I can tell you this equation here will always get you out of the woods. I hope that made sense, ladies and gents, and we will see each other again. Don't forget to subscribe and like and comment, and of course recommend the channel to as many people as possible. Otherwise, from me for now, I'll see you guys next time. Sharp sharp.